Greetings, Saintsman. This is lesson 3.3 for the proofs of parallel lines. This is going to be a continuation of something that we did in class. Make sure that you have your compass with you. If you don't have it because it's at school, I understand. Hopefully you have it along with you. I'm going to try to show you to the best of my ability right now in a really sketchy way on the screen where I'm going to do a construction. So I'm going to do the copy and angle construction. So we're going to start with that. And we've done this one before together. So let's go ahead and get, oops. Let's go ahead and get this construction going. So let's have a straight line, right? And I can make this guy straight because my software usually will do it for me. Oh, goodness. Gotta figure out where my autocorrect thing is. But nonetheless, I can actually use a straight edge here. So let's actually do that. Go use my straight edge. Do the best I can on my screen. All right. All right. Oh, goodness. I got a little bump there. Okay. And then from there, I'm going to take a point off of this. Oops. I'm going to take a point off of this line. All right. Now, what I'm going to do is effectively the copy and angle construction. So I'm going to take another point. What are we doing here? Struggling, guys, because I think my arm keeps touching this. And I'm going to connect these dots, these points, okay? So I'm effectively going to copy this angle here, okay? So what I'm going to do is I'm going to take my compass and I'm going to employ this on my screen. So I've got like my rubber tipped compass here. And I'm going to create two arcs, all right? I'm going to make this guy a little bit skinnier. Hopefully not scratch my screen. Here we go. So I've got an arc, okay? So I'm going to copy this angle here. Oops. Put this right through. Which I'm going to do the same thing where I'm going to keep this arc mark. So same size arc, right? Where I've got the same arc. I'm really struggling here, guys, with trying to do this on the screen. So bear with me here. It's very difficult to do on a tablet. Oops, I want to use a different color. I want to use blue. Okay, here we go. Let's try that again. Now, what I have here is I need to create this width of the arc, right? So I'm going to go through here and spread the compass to be the width of my arc here. So then I'm going to recreate this guy right here, okay? So now this is what I've got. Because I've copied this angle here, when I connect the dots, what it's going to give me here is the following relationship, which you guys are familiar with from class, right? So now I have these congruent angles, this angle and this angle. What's been formed off of them, because the angle is the same, and this is kind of coinciding with that notion we had of Euclid's fifth, where we have these congruent angles that are formed, and their relationship in this case are corresponding. So if we have two lines in a plane that are cut by a transversal and corresponding, that are congruent, then the two lines are parallel. Conversely speaking, or not conversely, moreover, this is what's called a corollary, right? It's if a point is not on a line, then there is just one line through that point that is parallel to the line. All right. So what I'm saying is let's actually work with a wholly different line. Let's use a different color altogether, green. This point right here, only one line through that point will be parallel, right? And which would be, just one line. That line, for example, okay? If I could actually draw it parallel. All right, let's actually do a proof together, gentlemen. This goes back to what we had been working on in class. So you're going to create the following diagram. It's that same two parallel lines that we have, right? Which I'm going to draw them. They look parallel, but I'm going to mark them as such, right? And they're cut by a transversal. I'm going to give these guys names. This is going to be line L. It's the transversal. I have M and N that are parallel. Ooh, M and N, not M and M. M and N. All right. And what we're given, because we have a bunch of angles that are numbered here. We have 1, 2, 3, 4, 5, 6, 7, and 8. And what we're going to be given is that angle 1 and angle 8 are congruent. So what we're going to prove and show, given that when we have those like corresponding congruents, right? That we have the parallels, then we can say that M is going to be parallel to N. I got a question, which was when dealing with the alternate interior angles. We're not there yet. We will get to when they're alternate interior, because remember that's based off of the proof of, hey, if it's corresponding and we have the congruence, then there's a parallels. If there's parallels and there's a corresponding, there's a congruence, right? It's the converse. And then moreover, we can put all of it together and prove all those other angle relationships. Alternate interiors are alternate interiors are congruent, alternate exterior angles are congruent, and then we have the corresponding, the consecutive interiors that are going to be supplementary. So let's do this proof here. Let's actually show that they are going to be congruent. So our two columns, left is statements, and we're going to have some proofs in our next class. Yeah, I know we got to do some calculations in the last class. That was nice. We'll have more of that, but we're going to have more proof. So angle 1 congruent to angle 8. We always start with. I'm going to restate what was given to us in the problem. Okay. So now what else can we establish from the diagram? Well, here we go. We have angle 5 and angle 8, and we're going to also know, oh, goodness gracious, guys. Angle 5 and angle 8 are they going to be congruent? And then eventually 1 and 5 we know are going to be congruent because of their relationship. So let's say that angle 5 is congruent to angle 8. And we know that because these guys are vertical. And moreover, angle 1 is going to be congruent to angle 5 because these guys are actually more so because of the transitive property, right? If 1 is congruent to 8 and 5 is congruent to 8, then 1 is going to be congruent to 5 because both are going to be congruent to 8 because it's transitive, right? Now, think about what your relationship is. What's the relationship between 1 and 8? Well, we already know that they're given as being congruent, right? They're alternate exteriors, but we know that M is going to be parallel to N, even though we have these alternate exteriors. But also, given this, right, when we have our corresponding angles that are congruent, which we do, 5 is also additionally congruent. We can also say that since 1 and 5 are congruent through that transitive property that we have the corresponding angles congruent, okay, that make those parallels. So, bunch of other things. We could work ourselves through all those proofs, but we're not going to. Going with the following or from the above theorem. I'll enlarge this so you guys don't have to strain your eyes. If we have angle 1 congruent to angle 8, then M is parallel to N. Which means if angles are alternate exterior and congruent, then your lines are parallel. right? So kind of we're proving really the converse of what we had, right, from the last class. If angles are, we can do the same thing, guys. Not just with alternate exteriors, but alternate interiors. And if consecutive interiors, remember we did all these proofs together. And then we can do the same thing. And again, this is kind of followed up with Euclid's fifth, but assuming he's correct, which pretty sure that he is, but maybe one of you guys will win that Millennium Prize, right? Then the lines are parallel. And then if two lines are perpendicular to the same line, then the lines are parallel. Which should make sense, right? They're perpendicular, then we're gonna have that supplementary relationship, which is like there being consecutive interior, or even the linear pair, and then we'll have the congruence, and of course there will be parallels as well. Okay. Um, that's all I got for today. So I'm gonna set you guys loose with your work in class. Good luck. I will have office hours in the morning.